we're going to be in chapter 7, but we're going to be in section 7.3. And in order to do 7.3, I want to take these numbers here and think about some number patterns, kind of as a warm-up. Because some of them you definitely know. If we were going to just look at a pattern, think of this as a warm-up for the day. What would be the next power of 10 in my pattern? Hey, Adam, what would you put down here? 10 to the third. Okay, so you can see the pattern. They're all base 10. So remember that the base is the big number, and then the exponent is the superscript, the small number. And you can figure out some of these with mental math. Like, Lexi, what's 10 to the second power equal to? 100, right? 10 times 10. So, Sam, what's 10 to the third power? 1,000, right? So, Connor, what's 10 to the first power? 10. So, if I move that, somebody asked about 10 to the 0 power.
0.
Well, look at the number pattern, Ingrid. It's 1, right? Because look at the pattern. We're dividing as we go up. We're really just dividing by 10 each time, right? If you think about it, 1,000 divided by 10 is 100. 100 divided by 10 is 10. So 10 divided by 10 is 1. So that is new. This is one of the new concepts of the day. Okay, so we're going to talk about if it's always 1 or just when the base is 10 in a minute. But if we continue with the pattern, Xander, what is 10 to the negative 1? Pardon me? Using the pattern, what's 1? Yeah, 0.1. And so that's true. It's 0.1. We want to think of it more today in fraction terms. It's a 10th. So if I add 10 to the negative 2 there, what would it be, Matt?
0.01.
It would be 0.01, 1/100th, but if I write it in fraction form,
Then
1 over 100. Okay, so I'm going to bring in a page here, look at both pages at the same time, and let's see if we can come up with some patterns here. All right, if you look at that 10 to the negative 2 one more time, it is 1 over 100, but that's also 1 over 10 to the second power. So can anybody think of a rule for when we have a negative exponent? How could I rewrite that as a positive exponent? Yeah, Ian. Well, using just what I have here without decimals, how does this become that? So let me ask you, let's look at one more. 10 to the negative 1, if we look at what we had on the previous page, was 1/10, right? And that's the same as 1 over 10 to the 1. So if I could ask you, what do you think 10 to the negative 3 is? In exponent form. Yeah, Emilio? 1 over 1,000 is one correct answer. Cameron? 1 over 10 to the third. Okay, so what happens when we have a negative exponent? Yeah, Xander. You have the same base, and the same exponent in the denominator. So the negative exponents make reciprocals. Do you remember reciprocals? Fraction reciprocals where it flips upside down?
Oh, yeah.
Okay, so that's one rule. Okay, so if we were going to write that rule algebraically, we'll just make a rule page here. The first rule that you're going to want in your notes, and I have plenty of examples, is when they write this like in algebra form, you'll see, if you see like a variable to a negative base, like we can call this, or a negative exponent, we'll call this negative a. The way you see the rules written in algebra books, first with letters. So that's the same as 1 over x to the a power. It's really hard to read those at first, so it's really nice to add with that rule a sample or two. Okay, so a sample problem would be if we put an example here and just said 5 to the negative 2 power. The negative, that negative tells us you're going to have a reciprocal. So you have a fraction now. You still have the same base of 5. You still have the same exponent of 2. But it's a reciprocal. So I used powers of 10 because it's easy for you to calculate them in your head. So that's true. And the other thing is, we would also say it is 1 over, not 100, but 25. Lost my focus. 1 over 25. Okay, so I'm going to pause so you can write some of this down. Okay, so there was another rule. If we look at, not that. If we look at the other page, can't quite get it. I'll bring that next to us. This page. Okay, what was the other unusual thing on this page that maybe you haven't seen or was surprising to you? Anybody? Yeah, Natalie? Yeah, 10 to the 0. 10 to the 0 by that number pattern is 1. So really the question is, would that be true for other bases? So we could do other number patterns. Like we could start with 2 to the 1 power and figure that out, and 2 to the 2 power and figure that out, and 2 to the 3rd power and figure that out. If we look at those, what's 2 to the 3rd power? 8. Okay, Natalie, 2 to the 2nd power. 4, and then 2 to the 1 power. 2. So, say, if I'm looking at this, really, I'm just doing another division problem. What am I dividing by to get from 8 to 4? 2. So, if I divide by 2, 4 divided by 2, I get 2. So, what would be the term that would go above 2 to the 1 in this pattern? 2 to the 0, and yeah, it's 0. So if I take this number 2 and I divide by 2, it's 1. So any number to the 0 power is always 1. So that's the second big rule for the day. So add that to your rules. So the way you would see that is, I'm going to erase this. You guys have that written down? The powers of 2. I could just shrink it. Let's do that so you can still see it. I will try that one more time to see if I can group it. And put it over there for you, Olivia. Okay, so the rule's still there, but on the rule page, we're going to say any number or variable. So any number to the 0 power is always 1, no matter what. You need that rule today. And if it's hard to believe, try to look at the patterns that we were just looking at. Yeah. Karen. You are. Every number to the 0 is, you're just dividing the number by itself, and that actually brings us to the third thing when we have division problems. Because yesterday we did exponents and multiplication, and today we're going to focus on exponents and division. So I'm going to bring in another page and talk about how exponents work with division. So a sample problem is probably the best way to start this. If we are looking at exponents and division, a problem would look like this. I would have a fraction bar. So a simple problem would be maybe 5 to the 7th power over 5 to the 4th power. Okay, remember fraction bars mean divide. So the long way to do this would be to write 5 times 5 times 5 times 5 times 5 times 5 times 5 out. And then on the bottom, I'd have 5 times 5 times 5 times 5. Okay. So, you know in multiplication you can cancel things that are the same. Like, do you guys remember from last year you could say 5 divides into 5 one time? Do you ever reduce fractions like that? And so this 5 would divide into that 5 one time. Remember that from last year? And this, you don't? Okay, so I need to go back to something simpler for a minute. We'll come back to this. So watch this. Let me ask you a simpler question. If I had 125 divided by 25, Noah, what's the answer to that? It's 5, right? That's correct. So I want you to start thinking as 125 as the product of 5. That's 5 times 5 times 5. Okay, and 25 is 5 times 5. So you can actually think of that as 5 divided by 5 is 1. 5 divided by another 5 is 1. And we're still left with 1 5. So this is 1 times that 1 5 that's left over. Do you see that? So if you have the same number, going back up here, going back up to this problem, if you have the same number in the numerator and denominator when you're multiplying, they divide out to be a 1. So all of these become 1s, and I'm left with how many 5s in the numerator? Yeah, Natalie. I'm left with 3. Okay, so this becomes 5 to the 3rd power. Now think about the rule we did yesterday. When we multiplied two numbers with the same base, what do we do with the exponents? Added them. And division's the opposite of multiply. So when we divide two numbers with the same base, so we have two different exponents, but the bases are the same base. They have a base of 5. We're going to subtract the exponents. The short way is to do 7 take away 4. So let's put that on the rule page, and we're going to practice lots of examples. So if you have two numbers with the same base, so b to the x over b to the y, that's the same as b to the x take away y. pretty hard to understand the rule like this. It's going to get easier when we practice some examples. Those are your 3 rules today. Okay? What time are we out of here? 15. Okay, so let's do a couple examples. And then I'll post this so you can practice at home too. So I typed up some examples for you guys. Here they are. And I'm going to have you guys hopefully have your rules written down so I can make this a bigger screen so you can see it in the back. And we're going to just practice with the examples. And if you don't want to write them down, that's fine. I'll post it and you can just watch and listen. Okay, so the first one is practicing when you have the same base. So we have a base of 10 and we have a division problem. You guys see that in the back? Better? So I'm dividing 2 numbers with the same base. So the long way would to have a bunch of 10s up here. We don't want to do the long way unless we have to. You see why? 1, 2, 3, 4, 5, 6, 7, 8. And then on the bottom I would have 4 10s. So the long way is kind of cumbersome. But what did we learn about this? It's 1, right? And this? 1. And this? 1. And this? 1. So we have 1, 2, 3, 4 10s left. So this is just 10 to the 4th. It is easy when you see it the second time. Yes. So you don't really want to go the long way, right? You want to just do 6 to the 14, take away 3, 6 to the 11, and move on.
Wait, is that the answer?
That's the final answer because of the directions. You're going to write each expression using a single exponent. So my single exponent is 11. Here I had 2 exponents. And this one, my base is -3. So I can keep it in parentheses. But the exponent is going to be 3. So that's one correct final answer. Another correct final answer is if you understand a negative to the odd power is negative, you could also write that as a -3 to the 3rd like that. But for tonight, if that's easier, stay with what's circled in yellow. See? Yeah. It depends on the exponent. This is an odd exponent. Does that make sense? Can I keep going? Everybody?
Yeah.
Okay, so that's using one rule. This rule is easier, but I put these in the order that your book did the homework. So this rule is just looking at your notes and remembering. Sorry, it's getting a little fuzzy. Okay, remembering what that negative exponent means. So if we look at the negative exponent here, what do your notes tell you? Instead of 7 to the -1, you want to simplify this. Simplifying means no negative exponents, or 0 exponents. In fact, you don't want exponents at all, is a better way to think of simplify. Unless, let me do a better job of showing you. If you can calculate the value, calculate it. So 7 to the -1 is just 1 over 7. So we can calculate that value. We leave it in fraction form. That's your answer. Can I do it better than say 4 to the 0? Right. So the value of that is just 1. Now, I can't get a numeric value for C, but I can do better. I can write it without a negative exponent. Zig, do you have a question or you have this one? No, that. 1 over b to the second.
Okay, so it's just 1 over.
It's just 1 over, like Cameron was saying.
Okay, 1 over the base.
And this one is going to be 1 over
Y.
y to the 3rd. Raise your hand if that makes sense. Okay. So the other thing that you're going to see is scientific notation with negative numbers. How many of you have already seen these in science? Okay, just a few. Do you remember when we had a positive exponent the other night? It took the decimal and moved it to the right? Because you're multiplying by a power of 10 bigger than 1. So when you multiply, yeah, you're going to move it to the left, right? Because really, this is just 3.1 times 1/100th, right? So it's going to get smaller. So for this to get smaller by 2 powers of 10, that decimal has to move twice. But it's got to go to the left because you're multiplying by a small number. So this is just 0.031. You move that 2 decimal places. How many times am I going to move this one? 4. And since it's negative, your number is going to get smaller, so you're going to go 1, 2, 3, 4. So 0.0004996. So we're almost out of time, you guys. But I think if you look at the book and maybe watch this, you'll be able to go through that homework. And then I'll be in here around 7:45 tomorrow if you want to come in and ask questions.